Okay, so two things I want to talk about. One thing is about the cross syntax that we briefly mentioned in class on Wednesday. So that could be very useful for not just lab 1 and possibly for future labs and the projects. And number 2, I want to talk about how you can do sorting using the comparator. Okay, you saw some little bit hints on the instruction, and we also make some sample code available to you yesterday. But I just want to go through with you the creation process. Okay, two things I want to talk about, and then after that I can answer questions. Okay, first of all, go to according to your lab 0, you can go to create a new project for iPhone Studio. Okay, just go to iPhone New website. On the terminal, you can also type iPhone New. Both work. Okay, let's go from the website. Let me call that maybe sorting. Okay. And then I'll say submit, and then it's going. Let me save it to maybe under my workspace 3311 and save it there. Okay, it's a zip file. Okay, and then if I go to my terminal here, I would see it's there. I'll say unzip sorting.zip. Okay, good. So now I have a folder sorting. That's my starter projects. Okay, I can now launch iPhone Studio. Okay. We try to do 2 examples in the same projects just to be clearer. Okay. Okay, you can add projects. Go to that particular workspace, sorting, and then sorting.ecf, and then open. So while it is compiling, let me talk about across syntax. Sorry, I forgot to set up my iPad. Give me just 10 seconds. Okay, over here. Okay, let's talk about the across syntax. Let me talk about the rule. The syntax itself is not difficult. It's just about the different options you can choose. You have to be careful which option you choose. Okay. Overall, the syntax you can use goes like this. The keyword across. Okay, and then you put something over here. Okay, and then over here you have an option. Either you can say is, or you can say as. Either way works, but you gotta be very careful when you do either. Okay, and then over here you have 3 options. Either you can say loop, or you can say or you can say sum, and then and. So all are keywords, and then put something over here. Okay, that's the overall syntax. And whatever you put over here should be something we call iterable. And we'll talk about the iterative pattern later in the course. But what are the typical examples for iterable? Any collection data structure, like an array or linked list, are iterable. So for example, you can put simply an array, or you can put a linked list, or you can put some integer interval. We have seen interval briefly last time on Wednesday, but we'll see all the examples here. Okay, so now let me explain quickly. So if you use loop, that means you're basically doing implementation. That means it should be only within the do body over here. That's the only thing. Okay? And if you use either or sum, so these are going to give you back a Boolean expression. And typically, you will use that either under require, or under ensure, or under invariance, typically. However, for Boolean expression, you may also use it in their implementation, but it's not typical. But we can also see example. Okay, that's the overall syntax. Let's see examples here right away. Okay, and then the subtle difference you have to know when you use it is to see when you use as versus is, there's a difference over there. One option there means you're using a cursor, not a value. Okay, we're going to see the difference. So let me go back to iPhone Studio, everything compiled. So what I will do is I will go to the tests and test example, and I'm going to delete everything else except for T0. We're going to build from scratch. Okay, I'm going to delete everything else. So only T0 is there. Okay, let me say that it's going to be testing the across loop. Okay, Let's start with something simple. Let's say array. If I declare local variable, local, and then names, array of string, for example. Okay, I can say create names dot make empty. Okay, that's how you create an empty array. And how can you insert to the end of the array? By the way, by default, for your information, by default, names.count, of course, it will be 0. And then, now, how can we make sure we can insert the element to the array one after another to the end? Okay, write down what you should write first, and then I'll explain. So you can say names.force. Let's say Alan over here. And then, what should I put as the first index, right? One way to do it, you can simply put 1. So to say we start the indices with 1. Typically, start with 1 for the indices. Another way to do it is to always put names.count, or whatever name of the array is, plus 1. Remember, initially, names.count will just be 0. So we are saying that I want to insert into index 1 for Alan, right? And then I can say names.force. I keep the same expression. And then I say mark. You can see at this point, names.count would have been incremented to 1. Right? So 1 plus 1 would be 2. So that means we're inserting into index 2, right? Etc. Okay, let's do one more. And then we say names dot force, and then Tom. And then over here we can say names dot count plus 1. Okay, overall we got 3 indices. Okay, and we can write a test right away, and then I'll show you how you can use across. We can say result is, first of all, names.count is simply equal to 3, and names.lower, lower is the minimum index, so it's 1. And names.upper, the maximum index, that should be 3. Okay, let's compile that. So the recommendation would be for every 2 or 3 changes you try to make to your code, try to compile right away. You don't want to say after 2 hours of my work, I compile, I got 50 different errors. That may not be very effective. Okay, just keep that in mind. So now if I say run, and then I say run workbench system. So I got exactly 1 test case is now passing, right? So far so good. Let's see how we can do the across. I'll show you a different example here. First of all, let's make sure are all the strings stored non-empty. I want to make sure every string that's stored in the array is not empty, right? I want to make sure that, okay? So now I want to say result, which is going to be a Boolean. Remember, it's a Boolean expression, right? To Boolean. I'll say result is assigned to. So now, what do I expect to see on the right-hand side? Some Boolean expression, right? So that means if you want to use across, you definitely can only use either all or some. You cannot use loop in this case because we're expecting a Boolean expression, right? Okay, just make sure that logic is clear to you. So now let's try the following. I can say the following. I can say across. In IFA, it does support code completion. As soon as you finish typing across, you say enter. It gives you something like this by default. Okay. By default, it's going to give you S and also loop over here. But it's not really what we want in this case. I would suggest do 2 things. Number 1, change that from S to is. Is easier for you to understand. Just use is. I'll explain S in a moment. Okay. And then in this case, loop is not good. We choose either all or some. So all is going to be a universal quantification. Okay, so now across something. So now remember what I said here. Anything you pass over here between the across and the is should be something that's iterable. And I can definitely use array. Okay, so what I would do is I'll go back here, and then I will say names, just the array itself. And then I can say for every element I'm going through in the array, give it a local variable, like a dummy variable name. I can say, for example, just name. So this name here can be anything except attribute names you have declared already, so you don't have any clash. Okay? Think about the name is a dummy variable of type string. Why should it be a string? Because if you look at the declaration for the names, it's an array of string. So every element there should be a string. That's why. Okay? So now inside this particular body here, we basically want to say every name I'm currently looping through, they should be non-empty. For example, not the case, name dot is empty. Or you can say not the case, names dot count is equal to 0. Either case, right? Either way. I'll write an alternative for you. You can say or names dot count not equal to 0. That also works. Okay, let me try to compile right away. Okay, let's see why. Names is name, not name dot is empty. Let me just see why I have that. Across all. Oh, did I forgot to create the array? Create names dot make empty. Let me just look through it. Give me one moment. Somehow they don't like this particular name.
Do you need to define that in the document?
No, I don't need to. I'm just curious. Let me see this. Maybe you have some clash. What if it's a across names is n? Let's see. For some reason, it doesn't like the name over here. I'll look it up and tell you. Sorry for the confusion. Okay, choose anything, not name. For some reason, name is clashing with something else. I'll look it up. Anyway, just choose any variable here. Sorry for the confusion. Anyway, it's compiling. And then if I try to run, okay, it's passing. Okay, I have an exercise for you. You can try. Okay, that's also a nice review of your logic. For those of you who still have some slightest recollection of 1090, okay, remember if I have for all, and then, for example, x, such that it is the case some property of x is satisfied, right? How can I convert that into there exists x? First of all, this is not equivalent. Agree? One is for all, the other one is exists. How can I make them equivalents? I need to put some double negation. Agree? So what I can do is I can say not the case and then not satisfied. Okay? If you're not too sure about this, speak to me afterwards. We'll review 1090 notes. Okay? But this is an exercise. What we just did was some across loop using across all. That's what we did. Exercise for you. Try to translate this guy here into this particular form. And then you're going to use maybe across sum. So sum is the other keyword that corresponds to there exists. So you can use either one. Okay? You can convert between the two. That will be exercise for you. Okay? Let's do another example over here. Let me go back here and let's see this. Any question until now about using across? Are we okay? Question, yeah.
When we use a force operator, what do we need to increment when names dot count? Does it do automatically?
Oh, okay, sure. Let's have a quick look. You can see the names dot force over here. Let me explain that quickly. Okay. If you look at how it is used, when I first say, first of all, names declared to be array of string. And then when I say creates, names dot make empty. After this, I should have an array that's called names. Conceptually thinking about it's pointing to something but just empty, nothing there. Okay. When I say names dot force, for example, just A. And then I say names dot count plus 1. Okay, first of all, names dot count currently is simply just 0. 0 plus 1 would be 1. So that means I'm adding A into index 1. That's what I'm doing, right? Let me just do one more to make it clear. Now if I say names dot force and B. I argue that we should really say names.count plus 1 rather than names.count. Why? Because if you say names.count, currently it is 1. That means you're going to overwrite whatever A is being stored over there. So if I say names.count plus 1 again. So now names.count is currently 1. 1 plus 1 is going to give me 2. So that means I'm adding it as index 2, and then with B. So keep going like this. Okay? Make sense to you? Okay. It's a very important pattern to note if you want to use array as your data structure. But of course, if you use linked list, you can just keep extending to the list. Okay? Either way. All right, let me go back here and then do a little bit more. Let's see how we can use across and then loop. How can we do it? Let's say I want to add another, let's say 5 or 10 names into my array, let's say. How can I write a loop to do it? Let's say across. So now, I don't really expect to return any Boolean. So what I will do is I'm going to follow this particular syntax over here. Okay, just the loop. So itself should be instruction. So now what I will do is I'm going to do this. Across, let's say over here, add 10 names into the array, like that. Okay. How about this? Add 10 empty strings into the array. Let's make it more obvious. So now, if I do this, I can first of all say across. Okay, across something. I know that I'm going to run basically 10 different iterations to adding the empty string. So now I want to make sure I run exactly 10 iterations. So every time, if you're pretty sure the exact number of iterations you want to run, use the across loop. That's the principle. So now I want to say, for example, 1 until over here, let's say 10. Oh, so this is another occasion where you can use the range. Because over here, we talk about whatever you can specify here can also be an interval. That's what we said in the class on Wednesday. Okay, so let me go back here. And then S, okay, again, change the S to is. Okay, I. Okay, so now you can think about I would just be any member in this particular range of 10 elements. I can be 1, I can be 2, I can be 3, all the way to 10. However, if you change this keyword back to as, it's going to be a little bit different. But let's not go there just yet. This is the easiest way for you to think about. Okay? Now, in this loop, what should I do? So now, I should have only a single line, right, to add to the end of the array. So now I can say names dot force. And now, apparently, I want to just add empty string into the array. And now, what index should I put to make sure I keep adding to the end? Names.count plus 1, as we explained, right? Because the names.count will keep growing dynamically. Names.count plus 1. Okay, let's do that. And then after it, I'll just say result is assigned to the Boolean. It's simply, let's say, names.count will just be equal to 13. Remember, we got Alan, Mark, and Tom previously, right? So adding another 10, that'll be 13. Okay, just make sure. And then I'll give you another exercise. Okay, everything compile, and then I'll just say run workbench system. Okay, everything still passed, right? It's more like a test-driven development, as we said in the tutorial. You try to make some modification to your code, and then you try to test it, right? Okay, so now I want to say a little bit more, and then I'll go to the edge comparator, okay? So far you have seen both cases where a cross loop is just going to execute a finite number of iterations and then do something, pretty much like a from until loop. On the other hand, when you are expecting some Boolean expression, like a for all will exist, you use across all or cross sum, okay? Let me just do another test case over here. Let's say T1, Boolean. Do, and then comments, T1, and then more across examples. I want to explain what if you don't really say is, but you say as, what's going to happen? T1. Okay, let's see this. Let's say we do the following. Let's say array A. Let's say ns for numbers. Array of integer. You know what? To be more interesting, let's put linked list. So you got different data structure, linked list of integer. And now what I want to do is I want to, let's say, add in different integers and make sure the list is sorted. Okay? So what I can do is I can say create names numbers dot make. So this will create empty list. And then I can keep adding different numbers into it. I can say maybe to say ns dot extend. Okay, for example, 23. Let me add in 3 numbers. 23 and then 89. And then I got 14. Apparently, this is not sorted, right? Let's make sure we can find it. Okay, so now, how can I be sure to write it across to see if that's sorted? Okay, first of all, should I use a cross loop? I shouldn't, because I do expect to have a Boolean result, right? So a cross loop can be eliminated, okay? You can either use a cross sum or a cross all, they're equivalent. Let's use a cross all, that's easier, okay? So now, if I say result is assigned to the following, okay? Let me keep s over here. Let me keep it there. So I want to show you what if you use s rather than is. So now across certain things, now what should I cross over? Should I cross over all the numbers, or should I cross over the indices? You see what I mean? Okay, let me make it clear to you. That's also a very common decision you have to make when you use a cross. So now I have 2 options for you. Numbers over here is a linked list of integer. Okay? Either I have to say across ns, or I have to say across 1 until ns.count. In this case, let's say we're going to use all. And then somehow over here, I need to write something that's to assert the list is sorted, right? I got option number 1. I got option number 2. Which option should I opt for? Do I have a choice, really? First of all, can number 2 work? Think about what number 2 is doing. Number 2, okay, somehow, if according to what we learned previously, you can say it is, let's say I, for example. I is going to be from 1 until the last index for the list, right? In that case, I can just be sure. If this is my list, for example, somehow looks like an array. If I have index I over here every time, I just have to make sure I is less than or equal to I plus 1, right? The elements. That's one way to do it. However, for option number 1, am I able to assert if the list is sorted? Am I able to? Thinking this way, if I go for number 2 over here, so that means, again, if this is my list, and then I say is, let's say, for example, I also put I here. Now, what would be the type for I in this case? Integer, I agree, but what does that integer really mean? Does the integer mean index, or does it really mean the integer that's being stored in the list? The element that is stored, exactly. So now, I is going to be either this particular elements, or this particular elements, or this particular elements, either way. As opposed to, if I'm in option number 2, I is going to be just indices, right? Notice the difference over here. So now, if every time I can only get 1 element at a time for option number 1, am I able to say I'm less than or equal to my right neighbor? Not really, okay? So now in this case, this is not the way to go, okay? So now we are unable to specify sorting property. Think about this case more carefully, because very often you have to make a decision whether what what collection you want to cross over. I would say crossing over the indices is definitely safer to go. Okay, let's go back there and see how we can encode it. If I go back here and then I would say across, I'll explain the S in just a moment. We're going to run into some trouble in just a moment. And then I would say from 1 until, let's say, ns.count. Let's say si. So now I presumably should be indices, right, in the list. So now I can say ns. Oh, by the way, for linked list, I will allow you to use linked list just as if it's an array. So you can use the indexing notation. Many of you may not have known this. ns, I can say at index I less than or equal to ns at index I plus 1. Okay, first of all, look at this. Okay, makes sense to you? Any questions? The only difference is we're using s over here as opposed to is. I will explain that in just one moment. But you got questions? Oh yes, I agree with you. Yeah, apparently we should maybe make sure it should be -1, because when I is exactly equal to ns.count, you don't want to say +1. You'll go out of boundary. That's good. I forgot to mention that. Okay, everything seems to be logical now. However, if I try to compile, it doesn't compile first of all. Let's see exactly what's a compilation error. Oh, if they say syntax, oh, I forgot. Of course, I meant all over here. Okay, but I notice that if you simply say loop, it's not going to compile simply because this appears on the right-hand side of an assignment. On the right-hand side, it should only be an expression. Loop is like an instruction. And it's a very common mistake in the lab test. Make sure you don't have that, right? Okay, let me change that back to all. But we might still have some error. Okay, compilation still failed. Let's see what it is. Okay, somehow non-compatible actual argument in the feature call. Usually, if you see this kind of error message, that means your type is not quite correct. Okay, let's see exactly why. Expand the error message over here, okay? And then it is basically complaining about this particular expression, NSI. Okay, I'll leave that to you to read a little bit more carefully about the error message. Okay, so now let me go back here and explain to you. So now this is our across. NS is linked list of integer. And then we say across. Okay, and then we say 1 until ns.count -1. S, I. And then we have n over here, and then we say all. The whole thing is going to be a Boolean expression. And now over here, we simply say ns at position I less than or equal to ns at position I plus 1. Okay, that's what we have on iPhone Studio. It is now complaining about basically this expression over here and this expression over here. It's complaining, okay? And the real issue is really about s. When you have s as opposed to is, you have to remember the I over here is not going to be just a value in the collection. It's going to be a cursor. Cursor meaning that it's going to be a pointer to something. So it's kind of indirect, okay? So now, let me show you this. The I over here, because it's S, is going to be a cursor pointing to some elements in the collection. In the collection. More precisely, I here is a cursor to integer. Cursor to integer. So that's why I said maybe easier for you to think about use is. If you use is, you don't have this indirection. So I will give you two options. Okay? But by default, if you use code completion, you always get S option. Okay, how can we fix this? Given that I is not directly integer, it's cursor to integer. You have to say rather than I, you have to say I.item. I itself is a cursor. I.item is going to give you whatever element is being pointed to. Okay, and then here, over here, I can say I.item plus 1. Okay, that's a subtlety you have to bear with. Okay, but maybe the easiest way for you to do is to always change that from S to is. That's the easiest way. Any question here? S is definitely talk about cursor, and is will be the element directly. Yeah, correctly. Yeah, you cannot use loop over here because it's expecting a Boolean, so you cannot use loop. Okay, so now how do I fix it? I would say I.item over here, and also I.item over here. Okay, that's what I should do. Okay, everything compile. Okay, and then apparently it is not sorted. So one way for me to say is it is not sorted. I can say result is equal to not result. Just say it's false, right? So now if I try to run every test, okay, I'm still okay. Guys, any question about across? Okay, good. Question, quickly.
Why did you make it false? Result make it false. Why did you make result?
Well, okay, how about this? I think this might be a little bit confusing. How about this? Result is going to be the testing result, first of all, right? I'll just say the current value of the result is such that result currently is simply equal to false. That might be a little bit clearer to you. I'm just saying it's not sorted.
How do you know it's not sorted?
Because over here you can see names, the numbers 23, 89, 14 is not sorted, agree? And then we simply try to set the result. You know what? Let me do this for you. Is sorted is Boolean. Okay, just make it clearer. Is sorted, apparently it should be false, agree? Okay, so now you can say result would be is sorted is false. I think that'll be better to avoid confusion. Okay, let me take another 10 to 15 minutes. Sorry for running over time, but I think it's quite helpful to talk about comparator quickly. Okay, let me first of all point to you. You don't have to type together with me. All the source code is already on the GitHub. Let me show to you very quickly how you can find it. Okay, if you go to this particular link, just go to your lab 0 GitHub link. You will see that under the same repository, under sample code, and then you will see lab 1 sorting. Okay, we put up the code yesterday. You can definitely download it and reuse it if you wish. We try to make the example so that it looks very similar to what you have to do for lab 1. But for lab number 1, you don't necessarily have to use a comparator. You don't have to. But I just want to show you how you can use it if you choose to use it. Okay, let me say in the same projects, I'm going to create classes for you. What I want to start with is, conceptually, this is what we want to do. Let's say at a runtime, we want to have, let's say, a collection of data cells. Okay, you can think about if I have an array called data, and simply an array, every element of the array is going to point to some cell. You can think about cell looks like this. Just call it cell, and the cell has just one element called item. Item itself we call generic. We'll talk about generic parameter later in the course. But could be maybe just an integer, or it can just be maybe a name, or it can be a binary tree. Doesn't matter. That's why it's generic. Okay, and then we can have as many data cells as we like. And now our goal is to say, once you have set up the data array like this with so many data cells, can you sort the data array automatically using quicksort, for example? But you don't really want to implement the sorting algorithm yourself. You can do it for lab 1, that's fine, but just make sure it's correct. But there's some facility over there for you. So the idea would be, we are going to create something called comparator so that the only thing we have to specify in the comparator is to say, for every pair of cells that the sorting routine has to use, how do we compare them? How do I know one cell is less than the other one? That's the tricky thing, right? It's quite easy to do. I'll just show you how you can do it from scratch. It's quite a nice pattern to do anyway. You can definitely find something similar in Java as well. For Java, you can just Google for comparator. I think something similar. Comparator versus comparable are the two main ways to use sorting, but we'll talk about comparator for now. Okay, let's go back here, and under model, okay, I just want to create a new class, and let's call that data cell. Okay, I'm just going to type exactly the same code just to explain to you quickly. It wouldn't take long. Data cell. Okay, so now I have a class over here called data cell. Let's make it generic, G. When I say it's generic, that means I can store anything in the data cell. So I have to instantiate G later. We'll talk about this process later in the course more theoretically. Okay? And now I'm just going to say I want to have only one constructor. Create, let's say, make a standard, make. So that means there should be a command called make, as we said. So now I would say feature commands. And then I would say make over here any argument G of type G. Okay? And then I'm going to say item is assigned to G. Notice one thing. Any clients of the data cell class, they have to commit to some actual type for G. For example, if the client says, I want to use string as a G, then every occurrence of G will be replaced by string. Okay? Later, we'll see that. Okay, one more thing to say, and then I want to make sure I do have the item there. I'll say attributes, for example. And then I would say item of type G. Okay, everything compile. Okay, a very simple class. So what you may want to think about is how does this data cell relate to some class in your lab 1? It should be quite obvious. Okay, I'll leave that to you. So we just need another class before we can sort data cells. All we got to do is create another class called comparator. So I will do is I'll say data cell comparator. Okay, so now over here, data cell comparator. Okay. Oh, let me just do one more thing. In order for me to make sure every time when I try to compare the data cell, every element is comparable, right? I want to make sure that constraint is specified over here, right? So now I have to say, so this guy here, dash greater than, is trying to specify constraint genericity. Okay, I'll put it here as a comments. Constraint genericity. In Java, if you ever program constraint genericity, you will use the word extends. The same idea. Okay, I'll just put a note here. In Java, it's basically like G extends comparable. But in this case, we'll just say comparable here. So this is to make sure every data cell is comparable, right? Their stored item is comparable. Okay, let me go back to data cell comparator over here. So now we want to make sure the comparator itself can also take something that's comparable. We'll talk a little bit more about how you can pass generic parameter around later. But for now, just for the demo. And then this is important, and this is somehow given by the hints for the instruction. I'm going to use the comparator from one of the libraries. So the class is KL comparator. And then I will simply put, so now you have to put something here to say, when the comparator is trying to do the sorting eventually, you're going to basically specify how to compare like a pairs of objects. What should be the type of pair of objects over here? In this case, we're going to compare pairs of cells over here. So that means cells should be units of comparison, not really item, just cells. So I'll go back here. So what I will do is I would say data cell and then G. Okay, and the only thing I have to do is to implement some defer feature. When we say defer in IFO, it means abstract in Java, which means when you inherit from this particular class, there is a single feature you have to implement. Otherwise, comparator wouldn't work. Okay, it would be, okay, I'll put it here. Attached less than U and V. Okay, I'll just leave the name it is from the inherited class. And then here we say data cell. So for every pair of U and V being data cell, how do we compare them? Okay, and then we say Boolean. Okay, so we should put something here. Okay, the idea would be, if I have these two data cells that I want to compare, so item here and item here, right? It could be one is 3, the other one is -1, for example. How can we compare them? Let's say if this is U and this is V. How do we compare U and V? You're going to say U dot item versus V dot item, right? Okay. So I'll go back here, and then I would say U dot item less than V dot item. And this is a Boolean expression. If you only write it like that, you're going to get compilation error. Simply because you are expecting to return a Boolean value for this query, but you should really assign that to result. Okay? Result is assigned to this. A very common confusion. Unlike in Java, there's no return statements for accessor in iPhone. You can think about it very implicitly, okay, if you want to think in that way. Implicitly return result as a last line. So you want to make sure the last assigned result value is the one you want to return implicitly. Don't write return. It's not there. Guys, any question until now? Any questions? Okay. So now one more thing, and then I'll leave you back to the lab. Okay. I'll make the recording available to you. Let's do just one more test cases. So now T2 over here. Okay, so now what I will do is I'm going to create another Boolean test case and then do. Okay, let's say we want to create, let's say 4 different data cells. Let's do strings. Okay. Oh, let's say still do integer. That's easier to understand. Local, let's say C1, C2, C3, C4. They are simply data cell. And now, as a client for the data cell, I have to commit to what should be stored in each cell. So let's say integer. Okay. So now, as soon as I say integer over here, let me remind you over here, if you go back to data cell, because at the client level I say integer here, that means the G over here will be replaced by integer. Every occurrence of G in the same class will be replaced by integer. We'll go through this process more thoroughly in class later, okay? But just for now. And then after that, we're going to have, let's say, comparator and sorter. I'll keep the names consistent with what you were told. Local comparator. And then I would say data cell comparator. And then I would say it should be integer. So every element that we're going to compare eventually will just be integer. Okay? And then let's say we got another one, L sorter, local sorter. And then I would say DS, that's a particular class you can use, array quick sorter. And then data cell. Okay, one more thing. And now let's say we want to store the cells to begin with. Let's say array. Since we're using array quick sorter, let's have the array. So let's say cells. Array of data cell of integer. Every time, if you're trying to use a generic class, make sure you always instantiate the G. Make sure always. Okay. Okay, we are almost there. Let me finish that. Comments. Okay, and then here you can say T2, and then sorting data cells. Let's create 4 data cells first of all. Okay, creates C1.make, and then I'll say 77. Let's create 3 more quickly. 2, 3, and 4. 2, 3, and 4. 77, 17, and 23. Let's say 46. Doesn't matter. Okay, and then we're going to say creates L comparator. Notice one thing. If you look at the comparator, data cell comparator, you can see there is no create clause for this particular class. Actually, if you look at the one of the parent classes, they already have the create clause. It's kind of inherited. Okay. So now, if you don't have any explicit create clause, you can just use a default constructor, just default. Okay. That is why you can simply just say create L comparator. It's as if you say default creates. But you don't need to say it. It's as if. Okay. Okay, once we create this, and then we're going to create a sorter. Okay, create L sorter. Okay, and then I'll say L sorter dot make, and then L comparator. Okay, make sure everything compile. Okay, everything compile. Okay, one more thing. We are going to also create the cells dot make empty. Okay, now some exercises for you quickly. Okay, exercises: add C1, C2, C3, C4 into cells. Okay, that's an exercise for you. And then how do we eventually sort this particular cells? It's very easy. I already got L sorter. It's a command. And then I will simply pass the cells over here. As easy as that. What it will do, remember pass by reference, right, from 2030. So it's going to basically rearrange the order of the cells, and then it's going to be sorted. Okay? So now 3 exercises, I'll write it down. Okay? Exercise to write these updates. And then another exercise for you. Before sorting, make sure cells are not sorted. Hint, use across. Okay, make sure it's not sorted. And then after this particular guy over here, you can do another exercise to say after sorting, they are sorted. Okay, so these are 2 exercises for you. The solution is actually on the GitHub. I would suggest give a try before you try to look at the solution. Okay, any question about what I've said so far? Go ahead. Sure. Yeah. Thinking this way, in order to solve this particular problem over here, okay, let me clean this diagram a little bit. Okay, let's say I got this many cells in my array. In order for me to sort it, I need 2 things, okay? Number 1, I need some sorter. Think about, first of all, I need to create some L sorter. And it's going to point to this particular, whatever, KL, whatever, quick sorter, right? And then that one there has a feature called sort, okay? So whenever I say L sorter.sort, it's actually going to somehow apply the quick sort routine. And remember what every comparison-based sorting algorithm is going to do at the most basic level. It's going to compare maybe element 1 with element 2 to see which one is smaller. And also it's going to compare maybe element 2 and element 4, which one is smaller. That's the most basic comparison. But how do we do that particular comparison? L sorter itself does not have that knowledge. So what you should do is, you should create another thing over here, L comparator. L comparator is going to point to this particular comparator, the cell comparator that we just created, right? And now think about the sorter itself is also pointing to this L comparator, so they would know how to compare between 2 cells. Okay? So that means when you actually do this line here, you're going to make sure when the L sorter, oh, I forgot to do one thing, dot sort. I forgot to do that, okay? If you say L sorter.sort over here, it's going to somehow use the L comparator to see how we can compare 2 cells. Okay? Any other questions? Go ahead, and then I'll take one more question, and then I'll stop the recording, and then we're done. Question? No, I'm not going to repeat again. Okay, that's why I'm recording it, right? Yeah. I'll try to make the recording available hopefully within 1 hour. Take some time to process. Okay, I'll stop the recording now.